Hi, my name is Kaylin Chapman, and what we're doing here is a group assignment project for an interactive video. And I would like to introduce everyone in the group. We have Donnie, Erica, Z, and my name is Kaylin Chapman. And so what we're going to do today is integration by parts. That's just my portion, and the others will have their assignments as well. So this is dealing with calculus. So what we have here is ln of x, and we're going to take the antiderivative of this with respect to x. And so from that, what you want to do with integration by parts is basically break it down into different elements. And you want to, what I denote those elements are as u, and I made ln of x equal to u. And I took dx and I made that equal to the derivative of b. And so to kind of show you a little bit further about what that is that I took the I want to fit that into a form of like something that's already been made and created for integration by parts, and that's uv minus the antiderivative of the du. But we have to get certain parts of these that we don't have yet. And so what we do to get that is to take the derivative of certain parts. And so the first part we have is u. I took the derivative of u, and that gave me 1 over x. What I did over here was I integrated dv, which is the same as dx, which came from this function. Remember, there was an x here. There's supposed to be an x here. And so that gave me v equals x. And so I take this information and I put it into this formula here. uv minus the antiderivative of v du. And so from this, my final answer and outcome will be ln of x times x minus the antiderivative of 1 over x times x. And then I take the antiderivative of that with respect to x. So I have my dx here. And so when I remember that x over x is really just 1, so I'm only taking the antiderivative of dx. And so my final outcome will be x times ln of x minus x plus my constant here, so plus c. And all of this is the antiderivative of the infamous function ln of x.
Okay. So now we're done with Kaylin, and we're going to go over to Z. He's going to show you how to do the disk method. And so you can go ahead, Z.
Okay, let me talk about something about this method. So if we have a function y equals to x squared, and let's put on this, so let's rotate the function by x-axis. So we will form a column like this. And so what is the volume? And so we are going to use the disk method, pi r squared dr. And on this case, the r is, the radians at this case is the function's value, r squared. So we substitute r squared, x squared into r back here. So we get x4 here. And we know we are trying to calculate 0 to 1. So from 0 to 1. And then x4, and then we antiderivative this function, and then we get x to the 5th over 5. And then we put 1 and 0 in, and then we calculate, and then we get pi over 5. The simple example. So if you don't get it, you should just that's the next question.
Alright, now we're going to go ahead and go to Erica. She's going to show you how to do some u substitution. She's going to do integration using u substitution.
Alright, well, with u substitution, we'll have to use some prior knowledge. For example, finding the derivative. The first step would be to find a u. And a u would basically be what's in parentheses or what's to the highest power. So in this case, our u would be x squared plus 1. The next step is to take the derivative of our u. So the derivative is 2x, because as you know, when you're taking a derivative, you drop the power, so you have the power in front, and then you take the exponent, and you subtract it by 1, which gives us 2x. We can divide both sides by 2 in order to get our du. Now we can set up our integral equation. So I pulled out 1/2 here, integral sign, and our u is u to the 4th. d, because we're solving it in terms of u. Next, we can integrate. And our formula for our integration is a x n plus 1 over n plus 1. A being your constant, x being your variable, and n is your exponent. So here, when we put this in our formula, we get 4 plus 1 over 4 plus 1, which gives us u to the fifth over 5. D. Now, we can pull out our 1/5, which is right here on the bottom, and we can sub in what we had before in the original equation. So we have x squared plus 1 to the 5th power. And the overall answer for that is 1/6 times x squared plus 1 to the 5th power. Plus. Thank you.
I want to make sure I'm doing this right.
Okay, so now we're going to do some basic, we're going to do a derivative of this function here. So in order to take derivatives, sometimes you may use these formulas based on the function that's given. And so for this one, we know that it's a quotient. We're going to use the quotient formula, which is going to be u times the derivative of z minus u times, this is actually, what's from the second one is going to be the derivative of u times z. And so once we take this function, we get u equals x2. Z is going to be x plus 2. The derivative of u is going to be, it's going to be 2x. And the derivative of z is going to be 1. So when we substitute it inside of the formula, we're going to get u, which is going to be x2 times the derivative of v, which is going to be 1. We're going to get minus the derivative of u, which is going to be 2x, times z, which is going to be x plus 2, and all of this is going to be over the denominator squared, which is u in this case, u squared, and so basically now all we need to do is simplify it.
No, leave the board.
Oh. Yeah.
Instead of using paper.
Okay. Oh, yeah, yeah.
No, no.
Yeah. Okay.
Because you're here.
Okay, yeah.
And we can also simplify it some more. So basically you can simplify some more, but this is the derivative of this function here.
You remember?
That's it.